Okay, today our objective will be to add rational numbers. Adding rational numbers, when we add rational numbers, we will use the same rules for signs as you used for integers. Alright, so for example, if we have negative 1/3 plus 1/6, first we have to rewrite those fractions with a common denominator. Common denominator for 3 and 6 would be 6. Negative 1/3 is the same as negative 2/6. Once we have that common denominator, we simply add or subtract the numerators. So once we have that common denominator of 6, we simply have to do negative 2 plus 1, which is negative 1, over that common denominator of 6, and we wind up with negative 1/6. So we have to make sure that we use the rules for adding integers. Alright, first example. Okay, we're taking a look at the following. We have negative 8 in the third plus 5/6. First thing we have to do is to rewrite each of those using a common denominator. Common denominator for 3 and 6 will be 6. So negative 8/3 is going to be how many 6? Well, that's negative 16/6 plus 5/6. Right, just a little mental math. 3 times 2 is 6, 8 times 2 is 16. So we're saying negative 8/3 is the same as negative 16 over 6. Right, we simply made an equivalent fraction by multiplying the numerator and the denominator by the same non-zero number. Right, the 5/6 doesn't change, but now we've rewritten our fractions using a common denominator. Once we rewrite them using a common denominator, we simply have to add or subtract the numerator. So we have negative 16 plus 5, and negative 16 plus 5, I use my rules for integers, so I'm adding opposite signs. When we're adding opposite signs, we have to subtract their absolute value. So negative 16 plus 5, that's going to be negative 11. Right? So we wind up with negative 11 over 6. Alright, now if we want to rewrite that as a mixed number, 6 goes into 11 one time with 5 left over, right? And it still has to be negative. Alright, so there's our answer, negative 1 and 5/6, but negative 11 over 6 is correct as well, just written as an improper fraction. Alright, so let's continue. When we're talking about rational numbers, we're talking about not just fractions, but also decimals. So here we have negative 4 and 5/100 plus 7 and 62/100. But notice that we're adding opposite signs. So when we're adding opposite signs, we have to subtract their absolute values. So you just want to come over here to the side and take your 7 and 62/100, which is the larger, the number with the larger absolute value, and we want to subtract the number with the smaller absolute value. Now, because I'm adding opposite signs, I'm going to subtract, but I'm going to take the sign of the larger absolute value number, which is going to be positive. So once I subtract, I know my answer is going to be a positive number. Alright, so when I subtract, I can't subtract 5 from 2, so I borrow from the 6, rename it a 5, that 2 becomes a 12. 12 take away 5 is 7, 5 take away 0 is 5. Decimal points we have to line up when we're adding or subtracting decimals. 7 take away 4 is 3. Right, so now I know my answer is going to be positive 3 and 57/100 because I have more negatives than I do positive. Alright, so let's take a look at these few examples here. We'll do each one just so that we have a pretty good idea of what we're doing and how we're doing it. Alright, start with problem number 1. Right, I'm going to rewrite negative 7 over 8 plus 1 over 4. I have to rewrite these fractions with a common denominator. Well, 1 over 4, right, and 7 over 8, common denominator of 8 and 4 is going to be 8. So that negative 7 over 8, I don't have to change. But the 1 over 4, I have to rewrite as 2 over 8. Once I've rewritten my fractions using a common denominator, right, I'm simply adding or subtracting the numerator. Here I'm adding negative 7 plus 2. I'm adding opposite signs. So when I'm adding a negative and a positive, we have to subtract their absolute values. Right, so that's going to give me 5, but because I have more negative than I do positive, it's going to be negative 5. The denominator doesn't change, right, so it's going to be 8. So problem number 1 should be negative 5 over 8. Let's try problem number 2. Negative 6 1/3 plus 20/3. Well, what's nice is they're already written with a common denominator, but I have to rewrite this mixed number as an improper fraction. So let's do that. I do that by multiplying 3 times 6, which is 18, plus 1 is 19. So it's going to be 19 over 3, right? But that was negative. But then we're adding 20 over 3. Once I have the common denominator of 3, I'm just adding or subtracting my numerators here. So this is going to be negative 19 plus 20. Negative 19 plus 20, I'm adding opposite signs. So I subtract their absolute values, right? So that's going to be 1 in the numerator, and then the denominator is going to be 3. That 1 is positive because I have more positive than I do negative. So 1/3 would be my answer for problem 2. All right. Let's look at problem 3. I have 2 plus negative 7 over 2. Now, there are different ways that you can, do this problem, but let's say it's probably best to rewrite using a common denominator. So 2 as a fraction is 2 over 1. And then we're adding, right, negative 7 over 2. So if I have to rewrite these with a common denominator is going to be 2. So 2 over 1 is the same as 4 over 2. So I have 4 over 2 plus negative 7 over 2. So now I have equivalent fractions with a common denominator. Right, so that's going to be 2, but we have 4 plus the negative 7 in the numerator. Now I'm adding opposite signs, so that means I have to subtract 7 and 4, which is going to give me 3. But we have more negative than we do positive. All right, and I'm going to write that over 2. So negative 3/2 would be our answer there. All right, let's look at example 4. Example 4, we have negative 12.5 and 15.3. Now I'm adding opposite signs, which means I have to subtract their absolute value. So we want to make sure that we subtract the smaller number from the larger number when it comes to absolute value. 15 and 3/10 has a larger absolute value than 12 and 5/10, right? But we have to subtract them because we're adding opposites. So when we subtract them, I can't subtract 5 from 3, so we borrow, rename, that becomes 13. 13 take away 5 is 8. To make sure we put a decimal point in our answer, 4 take away 2 is 2. Right? So we would have 2.8. Now it's a positive 2.8 for our answer because I have more positive than I do negative. So 2 8/10 would be my answer for number 4. All right, let's look at question 5. We have negative 8 and 15/100 plus negative 4 and 3/10. Here we're adding and the signs are the same. So when we're adding signs are the same, we actually have to add their absolute values. So that's 8 and 15/100, and I'm adding 4 and 3/10. We have to add their absolute values, but because they're both negative, my answer is going to be negative. All right, I'm just going to add a 0 here as a placeholder. Change the color so we can see that that's a placeholder. And now we add 5 plus 0 is 5. 1 plus 3 is 4. Decimal point in our answer. 8 plus 4 is 12. But it's going to be a negative 12 and 45/100 because I'm adding and the signs are the same. And we add their absolute values, keep the signs the same. All right, let's look at example 6. Example 6, we're adding opposite signs, which means we have to subtract their absolute values. So 2.75, that's the larger absolute value number. We're taking away the 65/100, right? That's going to be the number with the smaller absolute value. So we have to subtract. When I subtract, 5 take away 5 is 0. 7 take away 6 is 1. 2 take away 0 is 0. Right? And that's going to be 2.10. But here, notice that we're adding opposite signs. There are more negative than there are positive, so our answer has to be negative. So when we're dealing with rational numbers, we really have to pay attention to the sign. What will the sign of the answer be? Are there more negative than positive? Right? So we use the rules for addition of integers, and we determine the signs that way. Okay? All right, let's try evaluating an expression. All right. When we evaluate an expression, we want to replace the variable with a number. We're told to replace x with 1/4, replace y with -3/2. So this is going to become 2 times, parentheses, x we're going to replace with 1/4, and then plus y. Y is going to be -3/2. Now 2 times 1/4, that's going to be 2/4. So now we have 2/4 plus -3/2. Now if I want to rewrite these with a common denominator, right, we know that 2/4, right, the common denominator would be 2 actually, or it would be 4, all right, but we know that 2/4 reduces to 1/2. So I could actually take 1/2 and add the -3/2. And when I add the -3/2, this now becomes 1 plus -3, right, with the common denominator of 2. 1 plus -3 is actually going to be -2/2, which simplifies to -1. All right, so remember the steps. We're replacing the variables with numbers when we evaluate the expressions, all right, and then we have to use our order of operations. Okay. All right, here we have what they're calling a real-life application. It says that the table shows the annual profits in billions of dollars of a financial company from 2008 to 2012. Positive numbers represent gains and negative numbers represent losses. Which statement describes the profit over the 5-year period? Well, we're looking for, right, which one of these answers? Well, if this is the profit in billions of dollars, 2008 we had a loss of almost 2 billion. 2009 another loss of almost 5 billion. In 2010 we gained about 2 billion or 1.7 billion. 2011 was a gain, 2012 was a gain. If I want to know which one of these answers is correct, first we have to determine whether there was a gain or a loss, and then to find the sum of the profits. So we do that by adding all of the integers together. And if we get a positive integer, we had a gain. If we have a negative integer, it would be a loss. All right? So we start by adding all of our values together. Now right away we could see if we're using the commutative property of addition, we have -1 in 7/10, and I have a +1 in 7/10. All right, and then we have the -4.75. Right, we have the plus 0.85, and then plus 3.6. All right, these two values here, they're opposites, so they're going to cancel each other out. So now we have -4.75 plus the positive numbers. Now, in order to save some work and make the work a little bit easier, right, we're going to take the 8500ths and the 3.6 and add them together first. So we have 3 6/10, and we're going to add 0.85, and let's add them together. So that's going to give me 5. 6 and 8 is 14. Carry the 1, so it's going to be 4.45. So I have the negative, still have this negative 4.75, and then I'm adding 4.45. Now right here we should recognize that there's going to be a loss, right? Because -4.75 has a higher absolute value than -4.45, right? 4 4500ths. So if I'm adding opposites now, we have to subtract their absolute values. So if I know there's a loss though, I know I can cross out A and I can cross out B, because we have some kind of loss, so it cannot be a gain. All right, so let's do the next step. I need to subtract these two numbers, so 4.75 minus 4.45, all right, that's going to be 0, that's going to be 3, decimal point in 0. So now this is 3/10 of $1 billion, right? That's what that is. That's 30 hundredths of a billion, or 3/10 of $1 billion, right? But that is going to be negative, right? Because we have more negative than we do positive. So we have a loss of less than, or 3/10 of $1 billion. Well, $1 billion is 1,000 million. And if we have a loss of 3/10 of 1,000 million, right, that's going to be answer D. All right. Okay. Let's see. I think that's going to be it. All right. So hopefully that's going to be helpful, and we will see you soon.